quick chapter review on sections 5.1 through 5.3. Starting with number 1. So when we're multiplying algebraic fractions, we can multiply straight across if we want to and then simplify later, or we can simplify early. So let's take a quick look at doing it both ways. So straight across here, I'm going to get 28a when I multiply 7a times 4, 10 on the bottom. Simplify that. Okay, you can plug this right into your calculator, 28 over 10. And you will get 14 over 5. So it's 14a over 5. Okay, we also could have simplified some things early, 4 and 2. You can go ahead and cancel those down. So 4 divided by 2 is going to be 2. 2 divided by 2 is 1. And now when I multiply across, 7 times 2 gets me 14, and 1 times 5 gets me 5. So if you want to do that early, it saves you some big numbers in simplifying, but with the calculators, I'm not sure how much of a difference it really makes. So it's just whatever your preference is. So this one, I'm going to go ahead and simplify early. I've got 12 over 3, and I'm going to cancel that by 3, so I get 4 and 1. X cancels X, so that just goes away completely. Now multiply straight across, 8 over 5, and that's a good answer. Okay, for number 3, notice how I put the 10 up top. It's really a 1 underneath of it because we've got this fraction. We can go ahead and multiply across if we want to, but I know 5 and 10 are going to simplify to 2 over 1. There's nothing to cancel with the p, so I'm going to get 12 on top. The p needs to stay on the bottom, so the answer is not 12p, it's 12 over p. Okay, on this one, my a's are going to cancel. My 3 and my 9 can simplify down to 3 and 1. And these x's will not cancel because they're both on the top. So multiplying straight across, I'm going to get 6, and I'm going to get x squared from x times x. I will get a 1 on the bottom. So if you want to put it over 1, that's fine. But you don't need to. You can leave it as 6x squared. Okay, number 5. Now just simplifying the fraction. So I know that 121 and 11 can be simplified by 11. But again, if you didn't, go ahead and you grab your calculator and you do 121 over 11. And you can see it comes out to 11 exactly. Now, these C's are going to cancel, and these D's are going to cancel. So that's just going to leave me with a B, and it's up top with the 11. So technically there's a 1 on the bottom, but I can just leave it like this. All right, 24 and 32. Those can be simplified by 8, and I do have that negative. So if I put 8 into this, that's 3 times. If I put 8 into this, that's 4 times. Looking at my x's, there's 2 x's at the bottom. It's going to cancel 2 of these in terms of the exponent. This is really x times x. This is x times x times x. So canceling them one at a time, you can see there's going to be 1 more left up top because we had 3 compared to the 2. So I do need to make sure that I have an x remaining on the top. And with the y's, I have a 1y down here and I have 2 y's down here because of the squared. So 1's going to cancel, leaving me 1 still on the bottom. Okay, as we get to number 7 now, we're going to work on division. Very similar, we just need to turn it to multiplication by flipping the fraction before we can cancel anything. So the first thing I'm going to do is rewrite this. The first one stays the same. You change it to multiplication. and you get the reciprocal over here. So instead of 9 over 2, it's 2 over 9. I can simplify 2 and 6 early if I want to, so divide by 2, that's 1 and 3. And so when I multiply straight across now, I have c over 27. Okay, I have division. I'm going to change this to multiplication, so it's x over y times 2 over x. Oh, I'm sorry, that's a z, not a 2. So z over x. So my x's will cancel, and the only thing left over is a z up top and a y on the bottom. Okay, number 9. I'm going to go ahead and translate this directly to multiplication as I write it down. So the first fraction is going to stay the same. Instead of dividing by the 20 over 9, we're going to multiply by. It stays negative, but it's going to flip. So the 9 goes up top, and the 20a goes to the bottom. So these a's will cancel. Since it is a negative and a negative, I know my answer is going to be negative. I can simplify early if I want to. 9 and 15, you can simplify by 3. So we're going to get a 3, and we're going to get a 5. We have a 4 and a 20. Those can simplify early by 4, so that's 1 and a 5. So when I multiply straight across, I'm going to get negative 3 over 25. And number 10, again, I'm going to translate this directly. It's the negative 625x divided by this fraction. So we're going to start off with the negative 625. Put it over 1 if you want. Change it to multiplication. Flip the next fraction so the 8 goes up top. Now it's a negative and a positive, so my final answer here is going to be negative. And I almost missed that x right there. So that x is attached. So that x will cancel with this one. So they're gone. So my answer is just going to be a number. And I could simplify some things early. I'm just going to go ahead and multiply. I don't see anything super easy that pops to mind. So 5,000 up top, 50 on the bottom. Go ahead and divide that. And we get negative 100. Okay, 11. What value or values can the variable not have? So when they say what can it not have, that means what can we not plug in? What makes this undefined is the other way to ask this question. And so we cannot create something that makes us divide by 0. So what number would you plug in here to create a 0 on the bottom? So x cannot equal negative 8. Because if I plugged in negative 8, 8 plus negative 8 is going to be 0. Can't divide by 0. And number 12 now, I've got 4v minus 2.4 on the bottom. I don't care about the top, but down on the bottom, I cannot have this equal 0. So some number that I multiply by is going to give me a 2.4 so that when I minus 2.4, I get 0. So that's not one we're going to really recognize right off the top of our head. So we want to know, when does this whole expression equal 0? Just create a nice little two-step equation. Add 2.4 to both sides. So we're going to get 4v equals 2.4. And just go ahead and divide by 4. So 2.4 divided by 4 is 0.6. So v cannot equal 0.6. If we were to plug that in, we would do 4 times 0.6. We would get 2.4. And then 2.4 minus 2.4 would give us 0, which would give us an undefined expression here because we cannot have 0 in the denominator. So number 22, suppose a 225-mile train ride took 3 hours, letter A. what is the rate in miles per hour? So we read that from top to bottom, miles per hour. So that's the direction we're going to divide this to find out how many for 1. So miles on top, that's 225, divided by hours on the bottom. So when I go ahead and divide these two numbers, this will give me miles per hour, and 225 divided by 3 should be 75. So it's 75 miles per hour. Now part B, they're going to ask what's the rate in hours per mile. So let's make sure we understand the difference between the two. There'll be different numbers. This is how many miles in 1 hour. This is how many hours for 1 mile. Now, think about how fast this train is going. How many hours does it take for a mile? It's not even going to be a full hour. It's not going to take it 3 hours to go 1 mile. So it's going to be a fraction, okay, because it's going to be a fraction of an hour that it takes to go 1 mile. Small little piece of an hour to go 1 mile. So we're going the other direction, hours per mile. So we're putting 3 hours on top, divided by 225 miles. Now, if I did 3 divided by 225, okay, it does not give me a great decimal. You see the 3 repeated, but that's not 1/3. That's not 0.3 repeated. Okay, so I'm going to go ahead and leave it as 3 over 225, but I do need to make sure it doesn't simplify. So I'm going to put 3 over 225, and it does simplify down to 1 over 75. And this is hours per mile. And that should make sense if you take a look. If this was 75, it's really 75 over 1. And if we go ahead and we just flip the rate over to the reciprocal, it's going to be 1 over 75. So it's 75 miles for 1 in 1 hour, and it's 1/75 of an hour per mile. Okay, 23. You've got these two different boxes of pasta, and they have different costs. We want to compare the costs. So letter A, find the unit cost, or the cost per ounce, so dollars divided by ounces, cost per ounce, for the 16 ounce. So you're going to do $1.20 divided by 16. That's the cost per ounce. So $1.20 divided by 16. And when I get that, if you take a look in your calculator, it looks like this. Now we're so used to making that a percent, you might want to move that and make that like 7.5% or something like that. We're not talking percents, we're talking costs. So it's 7 cents. You might round it up to 8 cents. But in the real world, we're not rounding that up. That actually is going to be there. Okay, you can have partial cents when you've got a huge amount of things or they're really small. So let's go ahead and leave it just like this. So for part B, when we look at the unit cost of the larger box, it is $1.80, and there are 32 ounces. So we're going to do $1.80 divided by 32. Answer looks like this, 0.05. And then some more numbers. But as we compare these, it doesn't matter how many numbers we have that fills this out after the decimal. You go one step at a time. Okay, there's nothing here in the tenths place, so we go to the hundredths place. So it's 7 cents versus 5 cents. So for part C, which one is the better buy? That's going to be the larger one. That is 32 ounces. All right, and the last question, number 24. So it takes her 45 minutes to answer 32 questions. On average, how much time did it take her to answer one question? So whatever you want to get down to 1, that's going to go on the bottom. So we're putting questions on the bottom, which means minutes has to go up top. So we want to know how many minutes per question. How much time does it take her to answer one question? How many minutes per question? So we have to set up our division in that order. 45 minutes divided by 32 questions. If we do 45 divided by 32, Don't get a great decimal, so we're going to say approximately 1.4 minutes per question. And if you wanted to, you could leave it as 45 over 32 minutes per question, but obviously that is not going to be a fraction that we're going to talk about in everyday life when comparing amount of time. So 1.4 minutes, almost 1.5 minutes per question. Makes a little bit more sense when you express it that way.